Natural systems can throw us a lot of curveballs. A lot of things can happen that we're not really ready for.
The amount of material erupted from them, huge.
Yellowstone National Park has always been a natural marvel. It became a national park on March 1, 1872, when President Ulysses S. Grant signed the Yellowstone National Park Protection Act into law. It protected more than 2 million acres of mountain wilderness, amazing geysers, and vibrant landscapes for future generations to enjoy. However, recent news has added an element of caution to the experience. Renowned physicist Michio Kaku has made a significant announcement that Yellowstone is predicted to erupt in 2023, raising concerns about potential consequences for the United States and the world. In this video, we will delve into the details of Michio Kaku's announcement, exploring the implications for the future of the national park and the broader impact on our planet. Around 630,000 years ago, a massive volcanic eruption took place in Yellowstone, emptying a large underground magma chamber. The resulting volcanic ash spread over vast distances. Over time, the collapsed chamber formed a colossal 30-mile, 45-kilometer wide and 45-mile, 75-kilometer long caldera. Lava and sediments gradually filled the caldera, with lava flows continuing for hundreds and thousands of years. Approximately 160,000 to 140,000 years ago, the oldest version of the Grand Canyon of Yellowstone formed from rock and sediments, although it was not as deep, wide, or long as the current canyon. Hydrothermal activity, both past and present, weakened and altered the rhyolite rocks, making them softer. The Yellowstone River then eroded these weakened rocks, deepening and widening the canyon, an ongoing process. The present-day canyon starts at Lower Falls and extends downstream from Tower Fall. The 308-foot, 93-meter Lower Falls possibly formed because the river passes over more erosion-resistant volcanic rock compared to the downstream rocks, which have been hydrothermally altered. Similarly, the 109-foot, 33-meter Upper Falls flows over similar rocks, and the large rocks upstream are remnants of a lava flow resistant to erosion. The canyon's multicolored rocks result from the hydrothermally altered rhyolite and sediments. Observing the dark orange, brown, and green areas near the river reveals still active hydrothermal features. Their activity, along with the forces of water, wind, and earthquakes, continues to shape the canyon. And let's not overlook the fascinating Mammoth Hot Springs, where a unique combination of heat, water, minerals, and limestone has given rise to this captivating geological phenomenon. As hot water rises from the Earth's depths, it dissolves calcium carbonate from the underground limestone layers. This dissolved calcium carbonate, called travertine, is then carried to the surface by the ascending hot springs. Now, onto another remarkable highlight within Yellowstone National Park, the Upper Geyser Basin. This area boasts the highest concentration of geothermal features in the entire park. At its center lies the legendary Old Faithful Geyser, known for its predictable eruptions. If you want to witness a geyser eruption, this is the place to be, as the park can even forecast the eruptions of 5 major geysers in this impressive basin. However, here's the intriguing part. All of these geothermal features share a common element that should not be underestimated: volcanoes. Yellowstone is renowned for its close association with these mighty natural forces. Their impact can be observed and experienced throughout the park, contributing to its distinctive allure. However, something unprecedented and unnerving has occurred in Yellowstone National Park. A colossal crack spanning a staggering width of 100 feet has abruptly emerged in the region of Teton. This development has placed park authorities on high alert, prompting them to swiftly close off a significant portion of the park to conduct urgent investigations. Their objective is to unravel the mystery and comprehend the implications this event holds for the surrounding landscape. Teton is intimately acquainted with volcanic activity, owing to a convergence of 4 geologic factors. The first factor involves the presence of tough and resilient rocks at its core, combined with vertical uplift, the relatively young age of the mountain range, less than 10 million years, and the dynamic forces of destruction. The Tetons have managed to endure while other mountains in Wyoming, which possess similar rock cores and uplift, have succumbed to erosion over the course of 50 to 60 million years. However, the distinctive quality that sets the Tetons apart is the composition of their rocks. The majority of the Teton range is composed of some of the hardest, most durable, and least porous rocks found worldwide. Consequently, these rocks exhibit remarkable resistance to mechanical disintegration caused by fluctuations in temperature, ice, and water. The minerals within these rocks undergo minimal chemical decay due to the cold climate of the Tetons, while the absence of weak layers prevents the robust rock masses from collapsing under their own weight. Consequently, the Tetons can withstand the test of time far longer than an average mountain range. Despite their fortitude, the rocks in the Tetons do experience gradual degradation. The slopes of the highest peaks are littered with immense piles of broken rock or talus, signifying that even the strongest rocks have their limits. The process of frost wedging further contributes to their fragmentation. Water seeping along weak surfaces freezes and expands, eventually prying away slabs of rock from the mountain wall. This phenomenon, known as frost wedging, progressively causes slabs to tip and fall, triggering disastrous consequences. The perpetual conflict between the extraordinary toughness of the rocks and the prevailing forces that transport rock debris away from the mountains and lower slopes results in a perpetually evolving landscape, simultaneously beautiful and treacherous. Moreover, the power of running water cannot be underestimated, as it serves as an effective agent for transporting rock debris, particularly during spring floods, which can be devastating. All of this leads us back to the crack in the Teton area, where experts have identified expanding cracks in the rock. They are closely monitoring the crack for any signs of movement, which is particularly crucial because Yellowstone is currently recharging. Recharging refers to the filling of magma chambers beneath the Earth's crust with molten rock from deep below. Once these chambers reach capacity, the landform could erupt at any time, whether it be months or even millennia after the magma recharge. During an eruption, the chambers rupture, releasing an astonishing amount of magma into the atmosphere, potentially up to 240 cubic miles of explosive volcanic rock known as rhyolite. This type of rock is incredibly powerful, capable of penetrating the Earth's crust and holding the key to the volcano's destructive potential. Researchers studying the area are primarily focused on the plume of magma that heats the rhyolite from beneath. The goal is to determine the annual amount of magma recharging the volcano. To achieve this, they injected a stable radioactive isotope called deuterium into several hot springs within Yellowstone National Park. Despite sounding unconventional, this method is environmentally safe and has received approval from park officials. These hot springs are interconnected with a network of hydrothermal vents that play a critical role in the Yellowstone volcanic system. By measuring the temperature and tracking the time it takes for the deuterium to return to normal radiation levels, the researchers can calculate the quantity of water and heat flowing out of the springs. This non-invasive approach allows them to test their hypotheses without directly dealing with actual magma. Surprisingly, previous studies underestimated both the volume of water flowing through the springs and the amount of heat being released. It turns out there is a significant amount of water and heat present, transforming what was once believed to be a dormant volcano into a ticking time bomb. Scientists predict that it is only a matter of time before the colossal supervolcano awakens and unleashes a Category 8 eruption that could potentially impact the entire country. This possibility arises from the fact that Yellowstone is not just a single hazardous volcano, it encompasses the Yellowstone hotspot. This geological phenomenon has played a vital role in shaping the landscape of the northwestern United States over millions of years. And this is where Dr. Michio Kaku enters with his latest warnings. According to the renowned physicist, Yellowstone is set to erupt, a prediction he has been making for over a decade. He cautions that a Yellowstone eruption would have devastating consequences for the United States and bring about significant planetary changes. While Yellowstone is not expected to erupt in the near future due to its last major eruption occurring around 640,000 years ago, experts remain concerned about its potential for destruction. Continuous monitoring of the Yellowstone volcano is essential due to its capacity to become one of the world's most powerful volcanoes. Nevertheless, Dr. Kaku emphasizes that even with a warning, there would be limited options for preparedness. When it blows, it could destroy the United States as we know it. We're talking about immediate damage to the surrounding area. Up to 100 miles will see total devastation, basically wiping out everything. However, the real damage goes out to about 500 miles if you include volcanic ash, poisonous gases, and that's a ring which goes around 1,000 miles. It would wipe out the United States as we know it. It could happen tomorrow, or it could happen 100,000 years from now. It's black magic trying to predict when it will blow, but we do know one thing: one day it will blow. Mr. Kaku went on to add, "All you can do is run." Unfortunately, the experts keep reassuring the public that everything is going to be alright, but the shaking of our planet is getting worse with each passing year, and multitudes of people are going to die in these disasters. However, if scientists are to take Michio Kaku's advice, things might actually work out. And a NASA employee believes he has discovered a unique method to prevent a major eruption by introducing cold water into Yellowstone's magma chambers. Brian Wilcox, a NASA engineer, aims to counteract the threat of a super eruption by reducing the temperature of the magma within the volcano's chambers. Approximately 60 to 70% of the heat produced by Yellowstone dissipates into the atmosphere, but the remaining portion remains internally. If enough heat accumulates, it can trigger an eruption. According to the NASA employee, by drilling 10 kilometers into Yellowstone, it may be feasible to inject high-pressure water that would absorb some of the heat before being extracted. In Brian Walsh's book End Times, Wilcox shared that the plan could incur a cost of $3.5 billion, £2.9 billion. Additionally, this proposal would utilize the steam generated from the combination of water and magma to generate carbon-free geothermal electricity, which would be significantly more cost-effective than existing alternative energy sources. Mr. Wilcox explained to Mr. Walsh, "The thing that makes Yellowstone a force of nature is that it stores up heat for hundreds of thousands of years before it all goes kablooey all at once. It would be good if we drained away that heat before it could do a lot of damage." So what are your thoughts on Michio Kaku's warning and Wilcox's suggestions? Please share your opinions in the comments section below.